First of all, welcome to this webinar, or this speech of Astronomy and Culture, presented by the Dr. Andrew Munro and Stephen Gullberg, two professors from Oklahoma that will teach us about astronomy in different cultures. Dr. Stephen Gullberg is a PhD and associate professor at the University of Oklahoma, where he serves as lead faculty for the School of Integrative and Cultural Studies. He is the university director for Archaeoastronomy and Astronomy and Culture, and he also serves as chair of the Internal Astronomical Union Working Group of Archaeoastronomy and Astronomy and Culture. His work includes such extensive field research of the astronomy of the Incas in the Peruvian Andes and significant analysis of the Babylonian astronomical diaries. He regularly is invited to give presentations at a variety of internal conferences in his endeavor to globally advance the field of archaeoastronomy. In addition to Archaeoastronomy conference, he frequently is asked to talk about archaeoastronomy at astrophysics conference and speak to other fields as well. Our goal of this is to expand awareness and research of cultural astronomy in fields such as archaeology, anthropology, and indigenous studies. He also enjoys giving outreach talks to the public. Dr. Gullberg is a member of several commissions and working groups of the International Astronomical Union and serves on the editorial board of the journal Skyscape Archaeology and participates in many other organizations in the field, having also done work for UNESCO regarding its World Heritage List. Hello, Professor Stephen Gullberg. Nice to have you here.
And it's nice to be here. Archaeoastronomy, astronomy, and culture is a fascinating topic, and I enjoy talking about it a lot. So does Dr. Munro, who will be speaking right after me. And I guess with such a great introduction from Alberto, I don't need to say much more. So without further ado, I will start moving to share my screen with you. Just give me a moment. Oh, it says my participant screen sharing has been disabled.
Try now.
Okay. Yes, that looks better. Screen 2. Are you seeing archaeoastronomy and astronomy and culture? Not yet, you aren't. Now can you see it?
Yes.
We can.
Very good. That's just my opening slide. And of course, with the introduction that was given, I don't need to say anything more about that. The presentation plan that I have for what we're about to go through, I'll just briefly talk about the International Astronomical Union and their association with archaeoastronomy. So a little bit about archaeoastronomy itself, since it's, some people are more familiar with it than others. And then my primary interest areas that I'll talk about today, or I'll show some examples of astronomy in the Inca Empire and the Peruvian Andes, and talk a little bit about how they perceive the Milky Way. And I also have done some research with the Babylonian astronomical diaries that I will touch on as well. And just a little bit about education for astronomy and culture. The International Astronomical Union, of course, is the very huge worldwide governing body for astronomy. And within it, we have a working group for archaeoastronomy and astronomy and culture. And in our group in the IAU, we work to advance the field of archaeoastronomy, promote research and publication, promote strong initiatives for educators on different levels, and public outreach for astronomy and culture. The International Astronomical Union, the WGAAC, we play a worldwide central role in guiding the further development of the field. It's integral to the history of astronomy, and the group has members on 6 continents. So anyway, what is archaeoastronomy? Archaeoastronomy deals with the astronomical significance of sites and structures of prehistoric peoples. It's the anthropology of astronomy. Sometimes people call it that. What we're doing is studying how ancient cultures used astronomy, and for that it's important to talk about their cultures and their culture use, because they generally saw the world much differently than we do in Western science. And ethnoastronomy is another part of the field of cultural astronomy that deals with the astronomical systems of indigenous peoples. There's still, of course, very much living indigenous peoples in various parts of the world, and they still have their cultural, their historical, astronomical beliefs and uses, and we learn about more and more about what we can from them about those. It's important that findings are supported astronomically. The field is very interdisciplinary. There's astronomers, astrophysicists, there's anthropologists, archaeologists, indigenous studies scholars. Some understand astronomy more than others, but if it's going to be a cultural astronomy or archaeoastronomy, it has to be supported astronomically. And then also in the other direction, just collecting astronomical data alone doesn't do much good. You have to place it in a cultural context so that you know what the culture was doing with astronomy. Why were they using it? What did they believe? And depending on the records that cultures have left behind, sometimes it's easier than others to determine cultural context, but we have to work for it all the time. I'll just go through this next section really quick. I just wanted to show you that archaeoastronomy, cultural astronomy is not devoid of math. This is mostly spherical trigonometry that we use. And there's the basic spherical trig formula. You'd use these to calculate angles and distance to specify horizon points of celestial bodies. So you can verify field data that you're taking with a sighting compass, GPS, and theodolite. There's some more specific ones: the hour angle of the sun in degrees, the altitude of the sun, the azimuth of the sun. And the eighth one, the last one that I'm throwing out here right now, this one is the most useful for me, was in my research. This one gives you if you have an elevated horizon, like in the mountains or whatever, tables are going to give you a position for where the sun's supposed to rise on the celestial horizon, but the actual horizon is different. So this is how you compute where on the actual horizon things are going, the sun would rise or set or whatever. And of course, we don't have to manually work these formula. They're nice software that can do it when you input the numbers. Just as an overview, most of you probably noticed that when you're not in the tropics near the equator, you get further north or south, that the sun crosses the sky at different altitudes at different times of the year. This is for the northern hemisphere here, where at the winter solstice the sun crosses the lowest path over the sky, at the equinox a mid path, and the summer solstice the highest path. But this is what makes the sunrises and sunsets occur in different positions, and this is what ancient cultures noticed. They used these, this is for calendars, many of them did, because it was very dependable. The same day every year it rose in the same place, but it was constantly moving back and forth between the two extremes for the solstices. Some of the conditions that need to be taken into consideration: there's a precession of the equinoxes, the slow wobble of the Earth axis over 26,000 years. It's not a factor for the sun and the solar system. It's something that you might look at if you're doing an observation for an orientation that used stars a very long time ago. The obliquity of the ecliptic. Right now, it's 23.439 degrees, but it decreases about 47 arc seconds every 100 years. Again, for very ancient celestial measurements consideration, but not for anything more recent. Refraction. This is when you're observing something close to the horizon. About the first 20 degrees between the horizon and 20 degrees up, celestial bodies can appear higher in the sky than they actually are because of the light being slightly deflected due to differences in atmospheric density. Atmospheric extinction. This is scattering, the photons, the Rayleigh scattering and the Mie scattering. Same thing, kind of things that help us see a blue sky, but extinction's not an issue when we're looking at orientations of the sun and moon, but it could be when observing faint stars near the horizon, such as the Pleiades, for instance. And the one I talked about a little bit before, horizon deviation, occurs when visible horizon differs from the astronomical horizon. Mountainous terrain is where this is, readily happens all the time. And this chart just gives you a little bit of an idea. Altitude above the astronomical horizon, 1, 2, 3, 4, 6, 8, 10 degrees. This is the latitude of Cusco, Peru, where a lot of my research was. This is how much different the rise or set position is going to be for the number of degrees above the astronomical horizon. For a little further north or south, 40 degrees, you can see a little bit bigger difference of where the position is going to be. So this helps us predict and helps us to verify by knowing these numbers. But overall, precession is not a concern for solar observations, just for stars like the Pleiades. The obliquity of the ecliptic, like for my studies with Incas, it only changed 0.0649 degrees, so it's negligible there. Refraction and extinction are important when examining the rising setting of stars. They're not a concern for the sun, and of course the sun is very common for ancient cultures. The rising and setting of all celestial bodies, Cusco and everywhere else, must take horizon deviation into account. So let's get to some more specifics. My doctoral research was all of the Inca astronomy in the Andes in Peru. And I'll just give you some good examples. This particular photo here is at Yactapata, which is a site that's in the vicinity of Machu Picchu. We'll touch on that a little more later. But talking about cultural context, astronomy was an integral part of Andean mythology. The Incas, the rulers, they proclaimed themselves to be the children of the sun, and they worshiped the sun and viewed their emperor as being the sun's direct descendant. Whoops, no. The Incas made, they thought their emperor was the son of the sun. They made solar worship the official religion of their empire. And not only was the Inca the son of the sun, but his wife was the daughter of the moon. So the Incas venerated the sun, the Inca, and his predecessors. The ruling Inca was the central figure in their solar worship. Over many years, and of course the Inca Empire itself, from when it started its conquest of up and down the Andes between the southern Colombia and northern Argentina, that only lasted for 94 years, from 1438 to 1532, when the Spaniards conquered the Inca. But they had to, from many of their predecessors, with observations over hundreds of years, learn the astronomy that they would use, and they learned the cycles of solstices, equinoxes, and use this knowledge for their annual crop management activities and religious celebrations. Just north of Cusco, there's a site called Chaco Grande. It's a large granite outcrop. I should have a picture here instead that has people standing on it. You get a lot of people standing on top of Chaco Grande here at the same time. It's big. And on top of it, there's an interesting effect. The Incas were very big into light and shadow effects. And what they did here, they carved just off to the lower left of of the lower image here, there's a rock with a crevice in it that's aligned for the morning of the June solstice sunrise. And as the sun rises, the light will come through the crevice. It'll light first one of these carved gnomons, Sakankas, and then the other, and then they cast a shadow for the face of the puma. It's called the awakening of the puma. And the Incas had in their culture three most sacred creatures. There was the condor for the sky above, the puma for the world here and now, and then of course the snake or the serpent for the underworld. Inside of Chaco Grande, there's a cave with a very nice altar. The light comes down through here. And again, at the time of the June solstice, this is more toward local noon, the sunlight starts climbing the stairs. It starts just illuminating here, then it'll move up and have 2 steps, 3 steps, and then the top step as well, and it starts moving toward the altar. So they created that effect for whatever ceremonies they were doing. And there's the rear of the same cave, where there's another another altar, this one aligned for the equinox sunrise. Not too far from Chaco Grande is Laco, one of my favorite sites, actually, because of the astronomy that I found there. It's a another big granite outcrop, and there's 3 caves in it that have interesting features. And in this first slide here, this is in the southwest cave, where there's a light tube that they created that was aimed for a small altar inside. And while they wouldn't be necessarily looking out to see what was above, the light from the sun or from the moon would shine down on the altar. And I just took this photo to show that yes, the moon very definitely does line up with this light tube coming into the southwest cave at Laco. The Incas created this. This one is fascinating. On the northeast cave, I was talking about how the sun rises in a different position every day, dependably, throughout the year. So coming from the right, if you can see my cursor, the sunrise keeps moving day by day and gets closer and closer. And then this here is where it rises on the day of the June solstice. It stops. It's centered right on the cave opening. And of course, the solstice is a standstill. It'll stay there for a couple, 3 days, and then it'll start moving back again to the right. And while it is, and it's a wide enough cave opening there that you're going to get light in there for more than just that one day. It'd be a little bit before, a little bit after. But as you can see in this photo, it comes in and it illuminates the altar, and then the reflection illuminates much of the rest of the cave. And the altar had light touching it for 2 hours and 8 minutes as I watched the sunrise. The southeast cave is the most ornate of the 3. This is an entrance into the outer chamber. And talking about the sacred creatures, there's a snake or a serpent that's carved on the wall of the entrance. And then this had a light tube also, this one oriented for the time of the zenith sun in the tropics, where directly overhead, there's twice a year when a vertical pole will cast no shadow at local noon. The light would come down and come through the light tube and illuminate this altar for whatever ceremonial purposes that they designed it for. Kind of nearby and not exactly in between, but equidistant from both Laco and Chaco Grande is one called Waka 44. Waka is Quechua word for shrine. It's another limestone outcropping, much smaller, and this one is much more overlooked. But when we're looking at this, and there's these 2 circles that were carved, this big one and this little one, and this turned out to be a gauge to show them where to look for the main solar horizon events, because if you draw a tangential line between the big one and the little one like this, it points to the June solstice sunrise or the December solstice sunset. In this direction to the December solstice sunrise or the June solstice sunset, or directly across the equinox sunrise and sunset. So here again, this is the pointing at the June solstice sunrise, and here's the big one, and here's the little one, and the line between is pointing at the June solstice sunrise. At Caspihuanca, which is one of the palaces of Huayna Capac, who is one of the three emperors who presided over the conquest and expansion. There's pillars that are up on the top of a ridge that are still there. They're still extant. It's been recorded in the Spanish chronicles that there were a number of pillars built around the city of Cusco for monitoring the solar position, but the Catholic priests had them all totally removed and no trace left. But here, these are still there above the modern village of Urubamba and the remains of the palace. There's a little bit more close-up of the pillars there. When viewed from this granite boulder in the what was the center of the courtyard of the palace, that's a modern building that's up there behind it. This, by the way, is a theodolite that we use in archaeoastronomy. But viewed from this boulder, looking up the ridge, this is just a few days before the June solstice sunrise, where it'll rise over the right-hand pillar, then it'll keep moving to where it rises over the left-hand pillar at the solstice. And from that same boulder, here's the top of it, in this direction, it's December solstice sunrise, the mountain Cerro Unaraqui has these three little pillars on top, and they're oriented north and south, but it's also on the December solstice sunrise axis as viewed from the same boulder that in the other direction was looking for the June solstice sunrise. It's 4377 meters above sea level up there. And if I had more time, I've got all kinds of stories about that night, but I should save that for another day. So anyway, from the boulder, Caspihuanca, the June solstice sunrise, the December solstice sunrise, and then this also was not an unsupported look at the June solstice sunset over another peak, unsupported because there's no evidence that they used it, but it lines up that way. At the site of Chinchero, which is in the valley between Cusco and heading out toward Machu Picchu, everything there, not everything, but much of what is there is oriented exactly north-south and east-west, these walls. Now, of course, they didn't have compasses or GPS or anything, so it's very likely that they used astronomy with shadows and with a gnomon to determine south, and then north, east, and west could be established geometrically from that. There are a couple other ways that you could do this as well. But also the two major, there's a lot of wakas in Chinchero, but the two biggest ones, the one that, this is Kim Malville, who is my doctoral supervisor. He's on top of Titicaca, and then Chingana, the other one. It's quite a distance away because this is huge. These are both lined up on the axis of the June solstice sunrise and December solstice sunset, and that's a very recurring theme for the Incas. And that's just more of what I talked about how they could perhaps determine like the times the east-west equinoxes from the gnomon casting its shadow. Parabolic curve is the result. There it's down at Chingana, looking back at Titicaca where Dr. Malville was. And that's in the direction of the December solstice sunset. Choquequirá is getting a little closer to Ollantaytambo, the dropping off point to head out on the train to Machu Picchu. And it has a cave that's oriented for the December solstice sunrise. And of course, very nicely carved waka here. And this wall has these niches where they would put sacred items in. And here's Ollantaytambo. very, very prominent, striking set of terraces, 17 stone terraces here, and they're aligned for the June solstice sunset. June solstice sunrise was viewed from the pyramid of Pakartatampu. It rises over this very specific spot on the Pinkayuna mountain. And at the Inca Masada at Ollantaytambo, there's these gnomons that they carved in the side of the wall here. You can see them a little better. And there's a triangular notch down here so that at the time of the December solstice at local noon, the shadows from the gnomons come down and fill the notches below. But anyway, after Ollantaytambo, like I said, there's two ways to get out to Machu Picchu. You can either hike for 3.5 days, which is something many people do, or you can take a train for a little under 2 hours, which is generally what I did because I didn't have luxury of the time to enjoy the hike on the way out. But this is, of course, a very famous angle for photos at Machu Picchu that you see here. Any of you looked into Machu Picchu before, if you haven't been there, if you've at least seen photos of it, it's probably been similar to this. Now, there's some very interesting astronomy going on at Machu Picchu. And in this map of the region there, here's Machu Picchu itself. And I mentioned in that opening slide, Yactopata. In 2003, Dr. Melville, Kim Melville, and some of his colleagues rediscovered Yactopata. This is the cloud forest. It's like a jungle, only a rainforest, only it's in the mountains. And the vegetation is so thick that they found there was over 100 structures there, but they were so totally engulfed by the vegetation that even the local archaeologists had not really found them. This team did extensive searching to where they did identify these structures, and they were just 5 kilometers across the gorge from Machu Picchu. And then down in the bottom of the gorge below, another site called the River Intihuatana. Before Yactopata was discovered, it wasn't really understood what the River Intihuatana was for, but now it becomes obvious it was part of a much bigger ceremonial complex. And the 3, Machu Picchu, the River Intihuatana, and the Sun Temple at Yactopata are all on that axis again, the June solstice sunrise and December solstice sunset. And there's a potential second axis coming across the River Intihuatana for the equinox from the Overlook Temple, River Intihuatana, and Mount Machu Picchu. Inside Machu Picchu, the Torreon has a window open to the horizon, positions for the June solstice sunrise and the heliacal rise of the Pleiades. You can see the sun at June solstice coming in through the window there. The Temple of the Condor is interesting. There are certain scholars who think that the Incas also, besides paying attention to the days of the zenith sun, were paying attention to the days of the anti-zenith sunrise. Anti-zenith is when the sun's at nadir, it's below you, you can't see it, but it can be calculated, and the sunrise that they properly marked and anticipated on the day of anti-zenith was another valuable day in their agricultural calendar. There's just a drawing there of the sunbeam coming across on the day of the anti-zenith sunrise. And like I say, the days of anti-zenith could be determined by reversing the direction of sunrise on the days of the zenith sun to arrive at the position where the anti-zenith sunset would be. Gran Caverna is on the backside of, this is Huayna Picchu, the very prominent mountain there. There's Inca structures up on top here. But the Temple of the Moon, the Gran Caverna, is on the way down, halfway down to the river on the backside of this. Down, you still can't see it around the corner here. But when you get down to it, more structures. There's they're down here, things are oriented for the June solstice sunset. Here's some big niches. These are mummy-sized niches. The Incas mummified their rulers and other people after they passed away. And this was from the upper structure here, the upper cave, and the lower cave underneath is where the June solstice sunset light comes in. Here's the sacred plaza of Machu Picchu. This is, again, where the axis for the June solstice sunrise, December solstice sunset crosses. There's a semicircular platform there. That's the sunrise at June solstice. This is the Intihuatana of Machu Picchu, the upper one, but right off in here is where Yactapata's sun temple is. And the Yactapata Ridge, they're stretched out. The over 100 structures that are in the cloud forest there are stretched out. There's that picture again, where we're up at Yactapata, and we got there the day before and spent the night for the June solstice sunrise. And this beginning of this stone channel here is important, and I'll show you that in a minute, because that same channel, looking out this way, talking about how these were aligned. This is a ceremonial channel for ceremonial liquids. It's pointed at the sacred plaza at Machu Picchu, which is there. And the Intihuatana that I showed you in that picture a moment ago is just to the side of that. Then the June solstice sunrise and the Pleiades rise off on the horizon. There's the June solstice sun rising. The river Intihuatana and the gorge down below, another carved ceremonial stone with a lot of cultural significance. And I just mapped out the other structures. Here's the stone itself, the Intihuatana stone. I just showed you the other structures that were around it. From the stone down there, the Intihuatana, this is looking up to Machu Picchu, which is up here. You can see a little better there in the enlargement. So once again, this is back to the axis cutting across from Machu Picchu, the river Intihuatana, the sun temple, that axis for the June solstice sunrise, December solstice sunset. And we're just discovering what a much broader ceremonial complex this all turned out to be. Now the Incan Milky Way, the Incas, and they weren't the only southern culture, but that saw figures in the Milky Way. We call them dark constellations, but they're not constellations of stars. If you look at certain parts of the Milky Way, there's the interstellar dust gas that blocks the light from the stars of the Milky Way behind it. And so these dark parts, the Incas saw sacred creatures in their cosmology there. But before we get on to that, they also saw the Milky Way as two separate rivers because of the alternating position on the horizon each 12 hours. The plane of the Milky Way is inclined between 26 and 30 degrees with the axis of the Earth's rotation. The Milky Way at times will be viewed rising in the southeast, passing through the zenith, setting in the northwest, but 12 hours later, it'll rise from the northeast, travel again through the zenith, set on the southwest. The times of the solstices are the only ones when the sun rises and travels with the Milky Way. So that was a special time for them. The Incas ordered their sky by this quadripartition, and it gave them a nearly 90-degree difference in their perspective of the heavens from what we know in our ecliptic-based view of the sky. There's just a drawing of the quadripartition, the shifting of the Milky Way, giving them these four quarters. But back to the dark constellations, they saw shapes of beings formed by the dark clouds in the visible band of the galaxy, great cosmological characters meant to guide them. And this band of the Milky Way, the creatures stretch across nearly 150 degrees of the Milky Way. There's the serpent, the toad, the Yutu is a bird here, a mother llama, a baby llama, a fox, and another Yutu or tinamou. My wife is a very gifted artist. She painted this section of the Milky Way so we could draw the constellations on it. But there's Machquai, the serpent, and Hampatu, the toad, Yutu the bird, the mother llama, the baby llama, the Atok the fox, and the other Yutu. Like I said, there are other cultures that basically in the southern hemisphere mainly that saw things in the same section of the Milky Way. Yeah, Aboriginal Australians saw the emu in the same section of the Milky Way. Here's the mother and baby llama for the Incas again, and then in Argentina, the Manic, the Mokovi saw the Manic down there in the same section of the Milky Way. So you can see here's a picture of the Milky Way. There's the serpent there, and you get the toad and the bird, the Yutu. There's the mother llama, the baby llama. The fox is down here. The other Yutu. There's the Magellanic clouds there. I use them to kind of help me focus in. The coal sack is the Yutu, what we know as the coal sack. Babylonian astronomical diaries. Here's a different part of archaeoastronomy. The Babylonian scribes recorded positions of the moon and planets nightly for 700 years in cuneiform on clay tablets during the first millennium BCE. I did a study of that with astronomical software, trying to see what they were talking about when they said the moon or the planets were in front of, behind, above or below certain normal stars that were in the zodiac that, of course, the Sumerians and Babylonians created for us. These are all recorded on cuneiform tablets. Fortunately for me, they were transliterated into Akkadian, so I had to learn a little bit of ancient Akkadian, but it was far better than trying to read cuneiform. The diary entries describe topographical relations, like I said, such as being above, below, in front of, behind. They never found a tablet, though, that told what exactly they were talking about. So that's what I was looking for. And they also talked sometimes about distances in cubits and fingers. And I found when I was looking at all of these that the most observations were close to the sunset or sunrise. What I did was I took the astronomical software that could create the night sky map, a star map, and set it for Babylon in the exact position geographically and the exact time in the time zone, and then converted the dates from the regnal years in the diaries to fit the software, and created star charts. And it was exciting. The very first one I did matched exactly what the scribe had recorded 2,500 years earlier. So here, this was King Nebuchadnezzar II, the 37th year of his reign, in the month of Simanu. Turned out this to be the night of the 27th, 28th of June, 568 BCE. There's the Akkadian transliteration, but in English, it's night of the 8th, first part of the night. The moon stood 2.5 cubits below Beta Librae. So there is Zubina Shamali, Beta Librae, and there's the moon 2 cubits below it, 2.5 cubits below it. I drew in the moon, I put the moon in blue, and I drew in the line of the ecliptic. They didn't know or care about the ecliptic. They just, that's just there for our reference. Artaxerxes III, year 12 in Kislevu, which is turned out to be this date here, was the 17th, 18th of December, 347 BCE, the night of the 16th. Last part of the night, the moon was 1/2 cubit below Alpha Leo. It stood 2 cubits in front of Jupiter to the west. So there's Regulus, Alpha Leo, and the moon 1/2 cubit behind and 2 cubits in front of Jupiter. So you can start to see a pattern, and there's the ecliptic on that particular night. And Darius II, year 5, Ajaru, the month, 1 to 2 May 419 BCE. Night of the 7th, the moon was 2/3 cubit in front of Mars, the moon being a little high to the north. So there's Mars, the moon 2 cubits in front of it, a little high to the north. So as it turns out that, you know, and this is kind of what we suspected all along anyway, that they didn't really know about the ecliptic. They were talking about the general ecliptic path of travel of the moon and the planets. Above and below would be higher or lower in this direction, in front or behind to be further along or further back in this direction. They used this for celestial divination, not for horoscopes for people, but for the keys to the future, the king and the country. And I was able, like I said, to isolate that they were taking most of their readings in the early evening and late morning, and that they also found a few diary errors in the diaries or the transliterations, because what they recorded couldn't be supported astronomically. Education for astronomy and culture. It's fascinating. So, why do people sometimes seek out education? It's to satisfy curiosity, increase your knowledge. If somebody wants to get more involved, to develop appropriate research skills or publication skills, but the biggest reason, and this is, you know, certainly for not just astronomers, but anthropologists, archaeologists, to learn even more about a culture by examining that culture's use of astronomy. It's just a whole new dimension in what you can learn about a culture if you can identify and understand what they knew about astronomy and how they used it. There's just archaeoastronomy is kind of a new field. Just really started regularly getting journal articles and books in the 70s and 80s. So there's not too much education-wise available yet. There's a program with some undergraduate courses in Honduras. There's a graduate course in Argentina. One of those mass open access courses in Italy. They've been trying to start a PhD program in the Republic of Georgia. I heard it's kind of on hold right now. Hopefully it'll get going again. There's a program in Wales in the UK that I just mentioned because it's cultural astronomy and astrology. And of course, in science and astronomy, astrology is something that we tend to shy away from. Used to be a program at the University of Leicester for archaeoastronomy. Our professor, a good colleague of ours, Clive Ruggles, is now retired. And one of the early pioneers, Tony Avini in the US at Colgate University, has taught some archaeoastronomy courses. There's an indigenous astronomy for Native American astronomy course at the Northern Arizona University right now. But I'm just building up to where Dr. Munro, who will talk next, and I at the University of Oklahoma in the United States has now started a graduate program for archaeoastronomy. It's called Archaeoastronomy, Astronomy and Culture. We got graduate programs now. We're going to launch undergraduate programs in another year. There's individual courses. There's science-oriented archaeoastronomy. The coursework, everything that we've got, except for one course, is designed to be online, so anybody in the world can take it. And our part of the university specializes in online degrees and courses, and we're ranked among the top 10 in the United States every year for doing that. We have one course that we've set up for on-site. That's a field research in archaeoastronomy. We'll get students together at a place like Chaco Canyon, which Dr. Munro is going to talk about, to actually practice with the instrumentation for the theodolite and the sighting compasses and clinometers. It's an optional elective course. So if someone from another part of the world can't make it to where we're doing this in New Mexico or whatever, they don't have to, but it's available. There's just the courses that we've got. Archaeoastronomy methods, archaeoastronomy, Chaco Canyon, Latin American archaeoastronomy, beyond the Americas, culture, ethnoastronomy, indigenous astronomy in the US and Canada, field research. The undergraduate course is History of Archaeoastronomy, Astronomy and Culture, Positives, False Positives, Contemporary Cultural Astronomy, and Calendars, Culture, and the Cosmos. We're going to start adding more Native American astronomy, and someday we're hoping to get our own doctoral program started. But, you know, for anybody who's interested in astronomy and culture, yeah, this kind of education is important. In the past, people had to educate themselves. We're trying to help now. As in any field, proper education is the key to the future. I just quickly mentioned that, you know, I talked about my research of the Inca in Peru, and Springer just 2 weeks ago published my book that I wrote about astronomy of the Inca Empire, use and significance of the sun and the night sky. So it's kind of an exciting time for me there. But after that, I'm not sure, Alberto, or were you planning on having just one question period after we're both done talking? If so, I can delay answering my questions till later, or if you had intended that we do it now, I could do it now.
Yes, well, I will introduce Andrew Munro, the Dr. Munro, and then the question will be to both of us. And then, okay, we can. Okay.
Well, I will stop sharing my screen then.
I loved the presentation. I didn't have idea about the structures and the well placed that they are in South America, and how the Incas could do that. It's very interesting, and I can't wait to listen to Dr. Munro.
And you're about to see some very fascinating things that Dr. Munro has explored in an entirely different part of the world.
I will enjoy it, sure.
Thank you, Steve.
Well, I will introduce you, Dr. Munro.
Thank you.
Well, Dr. Andrew Munro, PhD, is an adjunct professor at the University of Oklahoma School of Integrative and Cultural Studies, like Dr. Gullberg, where he has led development of Archaeoastronomy and Astronomy and Culture curriculum. He also serves as a graduate astronomy project supervisor for the Swinburne University of Technology. His professional interests focus on Archaeoastronomy and Astronomy and Culture, including the role of visual astronomy in the development of science, spiritual, religion, and social power. In addition to his graduate and undergraduate teaching, he also supports public outreach presentations. Dr. Munro has conducted fieldwork-based archaeoastronomy research at Chaco Culture National Historic Park and outlying Chaco and Gate House, Site Science 2007. He has served as the principal investigator, field director, and permit administration for multiple national park service permits during this period. His PhD thesis and published work support the idea that groups of people with varied cultural traditions collaborated at Chaco Canyon, and they reinforced the magnitude of cultural change at Chaco after 1100 CE. Dr. Munro is a fellow of the European Society for Astronomy and Culture and maintains membership in the International Astronomical Union and its working group for Archaeoastronomy and Astronomy and Culture, along with several other organizations of the field. Welcome, Dr. Munro.
Thank you very much, Alberto. Thank you, Steve, and welcome to everyone who's with us today. Very much appreciate the opportunity to present my work to you, and I will proceed to share the screen here and see if we can talk a little bit about a Native American culture, which, as Alberto mentioned, was thriving certainly around the period 1000 in the Common Era, 1000 AD, if you will. The thing that particularly fascinates me about studying archaeoastronomy is not only that it gives us a window into greater understanding of the cultures we're interested in through our ability to study material cultural remains in the same way an archaeologist might, but using our unique astronomically based tool set, but it also gives us great insight into the origins of science, because all of the kinds of things that Steve has been sharing with us, the work that I'm going to share with you, these are indicators, they are strong evidence for the degree to which traditional cultures around the world used astronomy, the astronomical observation, as a tool set for a variety of purposes, to encode cultural knowledge and to increase the degree to which their cultures were successful, to improve survival potential. The particular culture we're going to be looking at, I will end up suggesting it's multiple cultures, but the culture area is often referred to as Chaco Canyon specifically, or the Chacoan or Chaco Phenomena. These, based on all lines of evidence, are people who are ancestral to modern Native American groups, often collectively referred to as Pueblo people, a Spanish term, of course, and a European labeling of groups of people in what is now the southwestern United States who shared certain cultural traits in architecture and dress and cultural practices. And what's fascinating is that in the area shown on the map, what borders what an American might today call the Four Corners region between Utah, Arizona, New Mexico, and Colorado, they built a real thriving center of culture. Really beginning in the 9th century, we start to see some expansion of scale, but by the 11th and 12th centuries of the Common Era, there were tremendous things going on here. The symbols you see on the map represent what are referred to as great houses. These are monumental structures, most of them built in sandstone, mortared, plastered. And if you look at the map, you see the small green ellipse in northwest New Mexico. That's the area where most of my field research has been conducted to date. That is the area of Chaco Canyon, the center of the Chacoan system. To put this in context, what's marked as the San Juan Basin on this map, this kind of gray area in northwest New Mexico, is entirely surrounded by mountains. The San Juan Basin itself is generally between 1,900 and 2,000 meters elevation, surrounded by much higher mountains, and it's thus in what's often referred to as a rain shadow. It's a very dry place, perhaps 24 centimeters of rain per year, most of which will fall within a 2-month period. So it's a very harsh environment. Temperature lows in the winter can go down into the 20s or even 30 below 0 centigrade. High temperatures in the summer up as high as the upper 30s or even 40 degrees centigrade. It's a harsh place, a difficult place to conduct agriculture, let alone build high culture. And yet, even in this photograph, you get a little bit of an indicator of some of the masonry that was being constructed in this place long about the time of, oh, well, you know, the Norman conquest, for example, in Western Europe. My research objectives started small and expanded, I have to confess. Early, a lot of my focus was on assessment and validation of previously published work. It turns out that Chaco Canyon is probably the most heavily researched archaeological site or group of sites, certainly in the modern United States, possibly with 1 or 2 exceptions in Mexico. I'm certain one of the top 3 researched sites in all of North America. And so there's a relatively robust body of literature. One of the great educational opportunities that I ended up having was to figure out which of that literature turned out to be effective and supportive of broader conclusions and which turned out to be not so well-founded. It turns out we have a mix of both. I used architecture as my primary touchstone. To be clear, there are plenty of other material cultural remains that I could have studied. There are specialists who do a lot of work with Chacoan rock art and ancestral Pueblo rock art, for example. Other kinds of material cultural evidence, pottery, serigraphic research. What's particularly wonderful about architecture is that because the climate is so arid in this part of the world, you'll notice in this picture at right, we've got what are called viga ends. These are actually remaining pieces of timber that were originally intended to support an upper story floor. And you can also notice in the window openings, as you look upward, you will frequently see pieces of wood supporting the window openings as framing. Those are all original, they're preserved. And through a technique called dendrochronology, the use of tree rings, we can actually get very precise cutting dates for each piece of wood. And as a result, it gives us a wonderful temporal boundary for construction sequences for all of this remarkable architecture. So that's why I chose to use architecture as my primary area of study, even though there are other archaeoastronomical possibilities. I look at building alignments and building orientations, and I'll talk a little bit about the difference between the two as we proceed. But simply speaking, an alignment is a more or less precise directional structural orientation between 2 points. So it might be, for example, a precise alignment of 3 buildings aligned in a row on a cardinal azimuth between due east and due west. Orientations are more general. We're talking about measurements with a broader standard deviation. And yet, if you look at sets of data, you will see that they stand out rather prominently. So they are lower in precision, and in some cases, we're not entirely sure what their purpose was, and yet they clearly were there. There was a lot in the literature about solar events, solstices, equinoxes, and also lunar events connected to what you'll sometimes hear referred to as the lunar standstill cycle. In the interest of brevity for today's talk, I'm really going to be kind of hitting just the high spots from the last 12 years of work. I'll share with you right up front, I have found no convincing evidence in my research for lunar standstill relationships at Chaco. Although I will share very openly that there are a body of colleagues, other researchers who disagree with that view and are quite adamant in their perspectives. How do we do the work? Well, a simple overview is to say we begin with literature review, but the literature review really covers a broad range of topics, and we'll talk a little more detail about that in a couple of slides. Archaeology is the touchstone, of course. There's a lot of published archaeology for these sites and for the regional system. There's also a fair amount of published archaeoastronomy, as I've mentioned. We also have lots of relatively good quality and lower quality ethnographic and anthropological reporting for descendant people, the modern Pueblo people who live in the 31 extant Pueblos. And a lot of discussion in history of religion and historical documents, either of astronomical practices or of these sites. So all of that needed to be input to the work that we've done. Between 2007 and 2015, we did extensive survey at 21 sites and subsequently integrated that with additional published site data when we could find high quality survey data and use, for example, orientation specifics for a particular wall to extrapolate further into the site, we would do so. Steve mentioned a good bit about the kinds of spherical trigonometric calculations that we can use for analysis, retrospective analysis of celestial positions of various objects, planetary objects, stellar objects. As a tool set for solar analysis and lunar analysis, the ephemerides that are maintained by the US Naval Observatory include a fairly nice tool set for local observations that allow you to include some of the effects that Steve was mentioning for things like horizon elevations, atmospheric extinction, and so on. And very importantly, I've come to view it as critical, just as you saw in some of Steve's work, to photo confirm predicted astronomical events. I'll share at least one example from the literature as we start looking at some sites where I can state with confidence a predicted published astronomical event does not function. It's commonly accepted in the popular world today. You will see it repeated over and over again in reports for the public out of scientific publications. Other archaeoastronomers repeat it constantly, and yet we found it had never been photo confirmed. And when we endeavored to photo confirm it, it does not function. So I've become a great believer in photo confirmation across the board. And increasingly, we're looking at this body of data that we've accumulated to try and support interpretation of meaning, looking both at the archaeological and ethnographic anthropological record to hopefully move away from simply identifying points of interest, identifying astronomical points of concern or patterns for these prehistoric ancestral Puebloan people, and actually begin to develop a useful tool set that can contribute, just as tree ring dates contribute to broader anthropological and archaeological inquiry. To dive just a little bit more deeply into the methods question, I'm not going to go through this processual view in great detail, but I just would share a particular hazard of interdisciplinary research. You'll notice at the top I've marked know the literature. As I mentioned a moment ago, we'll talk a little more about that. Understanding broadly what's been published for the culture and sites you're interested in. The formation of research questions and the selection of sites really needs to be driven more from the perspective of the humanities than it is from the perspective of the physical sciences. If we're trying to use archaeoastronomy to improve cultural understanding, cultural questions should be a starting point. Yet when we proceed into actual site survey, data analysis, integration, really looking to validate which astronomical events are plausible, which astronomical events we begin to see repeated from one site to another, increasing the likelihood of intentionality and cultural importance. It's all about physical science methods. Then again, when we get to the point to start doing the work of inferring meaning, trying to understand a bit more deeply what cultural intent might have been, we're back into the zone of the humanities. The reason this is so important is because it highlights to me something about our training as scientists. Both Dr. Gullberg and I had graduate training in astronomy. We are trained as physical scientists. Many of you who are on this in this meeting today are training as physicists. I've worked much of my career with physicists and engineering professionals who make use of physics developments. And yet much archaeoastronomy work depends upon also being conversant in the humanities. One of the things that I have found is that understanding the academic background of a researcher is often a helpful window into where their work will be stronger or weaker. And so just as an example, one of the cases I'll show you of a false positive here in the next couple of minutes is a case where a well-trained art historian looking at the particular geometry of a site and with a cursory understanding of the physical science methods and the astronomy, drew a conclusion which turns out to be entirely false. Not because they were ill-intended, not because they were even less than rigorous. They were rigorous with the tool set they'd been trained to. And each discipline in the Western Academy has a tendency to use quite unique taxonomy, terminology, methods, procedures, approaches, and we need to broaden our understanding when we start doing interdisciplinary research. In the case of my work, as I mentioned, archaeology is a point of dominance in the basis of my work, anthropology as well, history of science, a relatively small but important element of mathematics and engineering. The physical science component is actually quite tiny, even though that was my original graduate training. And as I mentioned, there was a lot of previous interdisciplinary archaeoastronomy published that I consumed and in some cases tried to either validate or ended up invalidating as I proceeded. So very briefly, let's look a little bit at cosmology, worldviews, and understanding of visual astronomy among modern extant Pueblo peoples. The first thing that's of great importance is that even though a person from Southwest Asia or Oceania or Europe or from Eurocentric North American culture might look at Pueblo peoples and think, well, these folks all look pretty much alike to me, there's great cultural diversity. Just to illustrate, we've got 4 different language families present among the 31 extant Pueblos with 6 mutually unintelligible languages and a wide variety of traditions, cultural, agricultural, ritual, and religious, linked at the level of pueblos, clans, and other kinds of social structures. And yet, in spite of all that diversity, we also find some widely shared common cosmological concepts. For traditional Pueblo peoples, irrespective of their cultural heritage, sky watching was both socially important and ritually important. Ritual and agricultural calendars tend to be very tightly coupled and interdependent because ritual activity is often directed towards agricultural success given the great challenges of growing crops in this difficult part of the world. We find that culture by culture, pueblo by pueblo, either the cardinal directions, which is more common among the eastern pueblos in the Rio Grande, or what we term the intercardinal directions, the directions of the solstice, rise, and set, as well as zenith and nadir, are important systems for grounding oneself and understanding your place in the universe. These 6-point traditions of cardinal directions are used in creation mythology. They are used in descriptions of geography. They are used for navigation. They are also very dominant in ritual systems. There are concepts of dualism and symmetry that we see very heavily repeated. And there's a concept that's a little bit difficult to describe, but I will endeavor to do so quickly, of center place. Center place often today is linked to the question of home pueblo, where are you from? But it's really much more than that. It's all about worldview. It's about how you view the cosmos, and it is derived from visual astronomy. To simply state it, if you imagine yourself at any point on the globe under dark skies without light pollution on a clear night, you can observe that the heavens are moving around you. You are at the center. That notion of center place, however, gets extended well beyond a simple observational reality into notions of cultural perspective, that people living together are at a center place, or perhaps seeking a center place to be more right with the universe, to have greater agricultural, ritual, societal success, as opposed to others who are at places other than the center place. So it's a really very deep concept that's rather hard to describe from the outside looking in. The other common thing we see is that solar horizon calendars and moon phase calendars are very important both ritually and agriculturally. And this piece of pottery is a very famous work from the Pueblo of Zia, which actually shows a sun symbol that is of such great fame today that it's also the primary motif on the flag of the US state of New Mexico. So these notions of connectedness to astronomical objects and deity go very, very deep in this part of the world. With respect to calendar keeping, Steve mentioned a bit about pillars that were created by Inca people around Cusco and perhaps by some of their predecessors. We may be familiar with the notion of calendrical circles in places like Western Europe, a site like Stonehenge, where we know at least we've got a good solstitial alignment. Native American people, especially in the Southwest, tended to use horizon calendars, and these are still used today by traditional practitioners. This particular example is from a Hopi village called Walpi, looking towards the west, the San Francisco peaks. It published by Steve McCluskey after work done by a man named Alexander Stephen in the late 19th century. The use of these calendars of marking sunrise and sunset positions against horizon features is very well documented. Secondarily, we often see cases where within architecture, light plays would be constructed. You can think a bit of some of the shrine sites that Steve showed us in the Inca world. But these light plays would be, for example, the sun penetrating through a wall aperture and perhaps going across the opposite side of a room. But everything we know tells us that all of those kinds of light plays tend to be lower accuracy and lower precision than direct observation of a horizon. So we believe that horizon calendars were probably used as a primary reference for a long period of time, because as some of these other concepts, they are a pan-Pueblo phenomena in spite of great cultural diversity. So let's talk a little bit about the framework I use to try and interpret what I'm looking at in the architecture. This drawing is particularly illustrative because it shows us two different types of architecture from two different periods, and we're going to look at examples of both as we go through the talk. First of all, we focus on visual astronomical phenomena. One of the things I found in the literature is this unfortunate, and from my perspective, ethnocentric tendency to apply modern worldviews, modern frameworks, sort of retrospectively into the architecture and see what we might find. And so an example of that might be identifying some potential astronomical target and then looking building by building for individual walls that might happen to line up with that target. Well, if we look at this floor plan, this is a well-known Chacoan great house, a monumental structure called Peñasco Blanco. We've got walls pointing in lots of different directions. If you think just about the neighborhood where you live in whatever city you're located in, I'm quite confident that if we spent the time, we could find a window in a room, in a building somewhere within a kilometer or two of your home that would point to some astronomical object of significance on an interesting date. Trying to figure out whether something is intentional and whether it's statistically and culturally significant needs to be a big part of this work. So we focus on visual phenomena and we focus on the overall structural alignment, what I term a front-facing orientation. So in this case, it's well illustrated. And essentially what we're saying is taller walls to the rear, shorter walls to the front, plazas to the front. If there is no plaza, perhaps an asymmetrical or C-shaped structure, the inner arc is more likely to be front than the rear arc. This process, by the way, is complicated because although many of these structures include doors, it was very common in this architectural form, because precipitation was so low, to use roof and ceiling openings more commonly than inter-room doorways. The other thing I would illustrate is that this larger structure in the view, Peñasco Blanco, the interpretive framework works quite well for it. It gives us about 113 to a 116 degree front-facing orientation, depending upon which walls or which mean you choose. To the right, you see this much smaller rectilinear structure. That structure was built a century or two later. It's emblematic of a later architectural form. There is no taller rear wall. There is no plaza. There's no higher wall. And from my point of view, it leaves us in a case where inferring a front-facing orientation is fraught with risk and not something I have done to date. Now, I can certainly record orientations for individual walls, but what I found is that that created a noisy data set. And in contrast, we found a very clean data set by looking at a different characteristic for those buildings. So let's first look at a structure that is probably the most famous monumental structure at Chaco Canyon. The picture at right gives you a nice view of how the canyon itself is carved down into the surface of the plateau. We've got very tall mesa walls. And because the precipitation is so intermittent, as I mentioned earlier, the wash or intermittent river that goes through Chaco Canyon, was called Chaco Wash, only flows a few days a year. And based on all available information, we believe that has always been the case, certainly back over 1,000 years to the time that the structure was being constructed. It's an artist's recreation of what Pueblo Bonito probably looked like at its heyday. And at left, we have a Google Earth image where I've got some survey results overlaid. You will note with interest, I hope, that the precision of the survey is actually quite high. The walls are very straight. And in terms of accuracy, the survey is also quite good. And having spent some time thinking through how one might use gnomons like an obelisk or a shaft of wood to use shadow casting to try and support survey, I would suggest to you that it is interesting that the north-south wall in this structure is at lower accuracy than the east-west wall. That's exactly what we'd expect if shadow casting was used to help support the engineering and survey of the building, which of course is not the same thing as proving that's the way it was done. But this is one of a set. Interestingly, like many other really large buildings at Chaco Canyon, this structure was built over a period of centuries with phases of construction and reconstruction, and it was reoriented in that time. Earlier in its evolution, it actually was a C-shaped room block, much like the picture we saw in the previous slide, but it evolved in a different direction and ended up being oriented pretty precisely to the cardinal directions. I mentioned a false positive that I would share. You can find it in the literature that this west-east fairly precise wall on the south side of the building is oriented to the equinoxes. That is not the case. The horizons are not flat on this location. We've tested it photographically and through survey, And not only is it not oriented with the equinoxes, aligned to the equinoxes, it also is not aligned to any of the what we sometimes call false or pseudo equinoxes that you might achieve through other means by things like day counting. So this is an example where our cultural biases, a Western astronomer, a Western trained astrophysicist, views the cardinal directions and the dates of the equinox as the same thing. I would suggest that when we're looking at this cultural system, the cardinal directions were clearly of great importance, and it's easy to conflate equinox, at least for this culture group. So it's kind of a risk of any interdisciplinary undertaking to think about what baggage we're bringing along from our training. A second orientation tradition that we see is to the south-southeast. Now, this group of buildings, and there are a lot of them, tend to be lower accuracy site to site, meaning that the standard deviation between sites is actually fairly high, covers a range of many degrees, depending upon the time slice, as much as 10 degrees. And yet a very, very common orientation tradition that we find. I'm convinced at this point, based on my research, that astronomy was probably of use in doing the survey to lay these buildings out. But I think a more likely cause for this orientation tradition is meteorological. It has to do with climate. And another cautionary note about worldview. Even as an astronomer, my use of the term cosmology, the definition is almost entirely different than the definition that would be used by an anthropologist. An anthropologist's definition has much more to do with the worldview of people, how they view themselves in the universe, as opposed to thinking about the cosmos as a physical entity and the Big Bang Theory and all of that. So for most traditional cultures, atmospheric phenomena and astronomical phenomena tend to be integrated into a knowledge system. They're not separate disciplines or domains. So we shouldn't find this surprising. But this orientation has dual benefits. One, it protects structures from the prevailing winter winds in this very harsh part of the world at high elevation. The second benefit is that it provides passive solar gain. A third orientation tradition we find is to the east-southeast. This is a site called Pueblo del Arroyo. And again, this is one of a set. These tend to be more precise. I don't have a good explanation for them. As we'll see, the folks who were building these buildings clearly had the capacity to pay close attention to solstitial orientations. These are not quite on the appropriate azimuth for December solstice sunrise, although some of my colleagues think that it may be connected to that. Other colleagues have suspected and published that they think it's to do with a lunar cycle. At this point, I'm not sure I'm ready to draw any conclusions, but it's certain that there are a group of these structures all oriented in that same common direction. So we've got three traditions that we see. I refer to the cardinal direction tradition more as an alignment tradition because of the high precision and accuracy, the somewhat lower precision of the east-southeast case, and the much lower precision, higher standard deviation for the south-southeast case, lead me to refer to those as orientation traditions instead. So let's go back and revisit our first site, Pueblo Bonito again. There is another effect visible from Pueblo Bonito that is connected to those horizon calendars I mentioned earlier. From the west section of the wall, for most of that wall, almost its entirety, better than 80%, June solstice sunset has a prominent horizon foresight that's visible. And that includes the earliest section of the building that was built in the late 9th century, a much older structure. Most of the horizon to the west is flat. There are two other small marks like this. And here we have a photo confirmation image of this June solstice sunset. Using the well-documented ethnographic practices of modern Pueblo people, we start to suppose that perhaps we will find similar sunrise and sunset markers at other sites where architecture is present. And that's one of the things that we've been looking for over the past decade or so. So let's briefly talk about how things changed over time at Chaco Canyon before we look at our next set of sites. And I will point out that most archaeologists would cringe at my left-hand column because I have conflated two distinct periods in Chacoan prehistory that have lots of differences. And I have deliberately abstracted those differences out for the purposes of simplicity in this talk. But even beginning in the late 9th century, certainly from the year 1020, 1040 up to about 1100 CE, we see multi-phased construction, increasingly large great house sites. Pueblo Bonito covers almost 5 acres, had over 600 rooms, and was either 4 or 5 stories tall. It was the largest masonry structure in what is today the continental United States until the late 19th century. So the people at Chaco were building really large monumental architecture. And yet they were using relatively inefficient construction techniques. If functional physical efficiency is what you're worried about, the walls looked like mosaics. And so they were clearly acts of devotion, if you will. There were hundreds of thousands of timbers consumed building the full set of sites within the canyon itself, and hundreds of thousands more in the surrounding vicinity. Most of those were imported from over 70 kilometers away to the west. And this was a culture that did not use pack animals or the wheel. We had large water control features constructed to support agriculture and water storage during the dry season. And there's well-documented evidence that after about 1070, certain high-placed lineage groups, elite families, began to move away from the canyon to areas in the north. And as I mentioned, we see these 3 orientation traditions to the south-southeast and east-southeast, as well as the more precise alignments to the cardinal directions as dominant features. 3 of the early sites have solstice horizon markers like the one I showed you. And we also know from the tree rings that long about the last decade of that century, there was a pretty severe drought. After 1100, things are very different. We see a large number of relatively compact, much smaller, much more efficiently constructed buildings popping up, much lower requirement for labor, lower requirements for sandstone because they're using much larger chunks of stone material. The masonry is more efficiently constructed, a lot less timber needed. During this period, we have 10 new buildings built at observing locations for solstice horizon markers, 4 buildings built where they are inter-site aligned, lined up between buildings along the cardinal directions. And we only went 3 or 4 decades and another severe drought begins. So we'll look first at these inter-site alignments. These were first identified back in the 1970s by a man named John Fritz. The model has been expanded over time, pardon me. As recently as 2014, our fieldwork expanded the model even further to include additional sites. It appears that the cardinal direction orientations that were present in individual structures like Pueblo Bonito in this last few decades of large construction were suddenly expanded, and the concept of the center place went from being the big monumental building to being the canyon in its entirety, encompassing all the buildings. That the orientation to the cardinal directions, which is implicitly cosmological, it's something you see across many cultures in the world. It's something you see, for example, at the Ming Dynasty Forbidden City in modern-day Beijing. We see it on the Giza Plateau. You see it around the world. That was being manifested here by the Chacoans as well. So I'm going back to Chetroketl because it gives us another example. You'll recall this is one of our south-southeast great houses. There's a proposed late small rectilinear structure, often by the archaeologists called a McElmo unit, built directly adjacent, just like we had one adjacent to our line drawing of Peñasco Blanco early in the talk. And that is positioned to observe December solstice sunrise, again, against a prominent horizon feature. And this is our horizon. And this is a confirmation image taken under really difficult conditions given the weather, using a less than ideal filter. And yet you'll note that the overall horizon profile, as I mentioned for Pueblo Bonito, this is about as broken up as most of the horizons get. In some of the buildings, when you're up on the mesa edge, they're even flatter, and you can go 80, 90, 110 degrees across the horizon with only one small bump to work with. And yet we see this pattern repeated over and over again, where architecture, especially these smaller late buildings, are constructed a place where that solstice, sunrise, or sunset event is visually available. Kinsabe, another very late site dating to about the same time, is probably my favorite site at this point because it's not there anymore. As I mentioned, this canyon was carved by an intermittent seasonal river called Chaco Wash. The lower image here, this stripe that you see up through the center, is actually a satellite image of Chaco Wash. That's the central watercourse. The broader watercourse extends out to the left side where this white box is, showing where the footprint of Kinsabe was. As late as 1920, an archaeologist named Neil Judd was documenting the site and gave us good photographic evidence, so we know what the masonry style was. But in the subsequent decades, erosion of the wash essentially consumed the building. Today, there's only a little teeny bit of rubble left up on the edge of the wash that you can see when standing down in the stream bed, as the picture at upper right shows. And yet, from the location of this building, again, we have a December solstice sunrise marker on a prominent marker that's against a mostly flat horizon. So here we see the horizon profile on a day when my team and I were out doing our initial survey, and then a much later confirmation image we took the following December. I will point out that physicists, for some wonderful reason, are often drawn to this work. Even though I'm not trained as a physicist, I'm an astronomer. The person in the foreground who's helping me is a helioseismologist named Sherilyn Munro, and the gentleman directly behind her, John Nickerson, was at the time a graduate physics student. So lots of folks with physics backgrounds find this work fascinating, I think in part because of its connection to the origins of our scientific worldview and the very sciences that we practice. So an integrated view of the data, greater than 90% of the 21 structures we've studied, either based upon initial building starts or reorientations, fit to our framework of 3 traditions for orientation or alignment, and the presence or absence of a solar horizon marker for a December solstice or June solstice sunrise or sunset. And another interesting side note in terms of colleagues who've come to help the gentleman in the foreground here in front of Dr. Munro is a really well-renowned developer and manager of space platforms. He's my dear friend, Tony Hull, who to this day consults extensively for the European Space Agency and NASA. His last full-time position was as the program manager for the Spitzer Space Telescope. And yet, God bless him, he made time to come out and do horizon sketches and survey work in support of my research, for which I'm very appreciative. And this is, in my mind, where it gets even more interesting. As I mentioned earlier, my great hope is to take some of this work, and at least for the culture groups that were present in the southwestern, what is now the southwestern United States, the San Juan Basin, ancestral Pueblo people of this time frame, I'm hoping to help develop a tool set that has utility for the archaeology community. That is not to say that all archaeoastronomy must have such utility, but that's part of my objective. And so you'll notice that time period by time period, we've got very significant differences in what is dominant, what's going on within the archaeological record. Early at Chaco, almost every building is facing to the south-southeast. 2 of the buildings that were constructed also had solstice horizon foresights. We've got 1 east-southeast and 1 that doesn't fit the model. Early in the 11th century, we start to see these cardinal alignments, and you'll notice I use the term reemerge on my slide. If we looked back some hundreds of years earlier when people were building much smaller structures at Chaco, you will also find a pattern of mixed south-southeast and cardinal direction alignments. So it looks like groups of people migrated away and then migrated back. Perhaps these orientation and alignment traditions can be used as a culture marker. This east-southeast orientation tradition and the building to the cardinal directions dominated in the late portion of that century. And then after 1100, everything's quite different. Much smaller buildings, a whole new crop of them built at once. And this fixation on the cardinal directions and marking solstitial horizon markers, I think is indicative of very great importance being attributed to sun-related ritual practices. So I think the big change, we can say that the changes in cosmology reflected in the architecture hopefully can be a guide to changes in the organization of the culture and the system. Early on, we've got a good indicator here, supported by many other lines of archaeological evidence, that we had multiple cultural traditions collaborating at Chaco. That is not a new idea. This is a case where our archaeoastronomy data notches beautifully into mainstream archaeology thinking in terms of what went on at Chaco Canyon. What's kind of wonderful from my point of view is that during this late Bonito phase after AD 1100, we've got a dominant cultural objective. Construction at sites with the solstice foresights, elevated importance for solar events, expansion of this concept of central place to encompass the whole canyon. And I believe increasingly, although I have to convince my colleagues in the archaeology community, that these new little rectilinear structures were probably specialized spaces for performative rituals. So that gives you an overview of the work that we've been doing. And Steve shared a good bit about the graduate certificate program we've been developing at OU. I'll share a little bit more about that here. But just as a backdrop, I would reiterate that one of the things I find particularly helpful to me as a practicing educator and a research scientist in doing archaeoastronomy work is that the forced exposure to interdisciplinary research really helps broaden my thinking. It helps me take a step back and think about what my own filters and assumptions may be, which I think is always beneficial in any form of research. And so I suggest that that may be true as well for many of you if you find this at all interesting. And with that, I am very happy to take questions along with Dr. Gullberg if anyone has any.
Thanks, Dr. Munro. I loved the presentation. It's wonderful and impressive how many structures and the meaning there are in the only in America, maybe in other countries there is many others.
Alberto,
you'll find it most everywhere in the world, Alberto.
Yes.
Ancient cultures all observed and used the sky in their cosmologies.
It's an interesting irony that I think archaeoastronomy and cultural astronomy tend to be more established and better accepted in Eurasia, Africa, Oceania than they are in North America. Certainly Latin America, it's better accepted. The simple reality is, one of the reasons Steve and I try to be so rigorous in our work is that there's been a fair amount of poorly founded work published in North America. And as a result, the archaeological community tends to be particularly suspicious. And I'd say for good reason.
These weren't serious researchers like us. They were many times amateurs who went out on their own without proper training and education and knowing how to do proper rigorous research and came up with, well, you know, the idea of ancient astronauts and things like that. That sort of thing.
Okay. I have a question, a couple of questions. The first of all, your work is undoubtedly interdisciplinary. What is it is like to work with people of other fields?
You'd be a good one to start out on that, Andy, since you've worked with archaeologists quite a bit.
I'm happy to do so. Thank you for the question. So it's actually quite wonderful and quite challenging all at the same time. It took me a period of time when I first started doing this research to identify a group of colleagues in the archaeology and anthropology community who were even open to the work we were doing. But I also had the good fortune to have a graduate supervisor who recognized the extreme importance of linking this kind of research to anthropological and archaeological standards and inquiry. And as a result, for example, my PhD thesis, the thesis review committee of external reviewers, not at the university, but all the external reviewers were all degreed archaeologists. They were not astronomers or astrophysicists. Within the university, there were astronomers and astrophysicists involved. So even from the perspective of doing the graduate work, I had that good fortune. And ultimately, some of the folks that were involved in reviewing that early work became willing colleagues. It has become wonderful and enriching because we have different language, we have different tools, we have different approaches. And so it really enriches the iterative nature of the research work. I will do a draft research design thinking about a particular site and define my research plan, put it in the hands, for example, of my colleague, Joan Mathian, who is a career-long archaeologist for the US National Park Service, very well-regarded, very conservative archaeologist. And she will immediately, because of her encyclopedic knowledge of the literature and the sites, be able to come back and make all manner of very helpful recommendations on how to improve the research study and the site planning before we even, begin to book travel. So it's lovely, but it's also challenging because often we find ourselves in situations where we are dealing from different knowledge bases. And for example, much of my understanding of positional astronomy, use of spherical trigonometry as a tool set, ephemeroids, all of that is, well, it's Greek to my archaeological colleagues. And similarly, I know that I have learned enough about their field to, as we joke in some of my other work, I become a hazard, right? I know a little bit about archaeology now, but I need to be cautious to not extend my reach beyond what I really know.
And what Andy's been talking about there, the actual collaboration with others in the other fields is the best. But as he started touching on as well, when that isn't available, like for myself, my background is in astronomy, but I had to learn a lot about anthropology and some about archaeology because of the interdisciplinary nature. Even if I was doing the work myself, I had to cross those boundaries. And there's other colleagues of ours who are anthropologists who have had to teach themselves astronomy so they could properly understand what was going on and to continue the furtherance of their research. So those are the two different ways that this is interdisciplinary, with one individual trying to become at least conversant in the necessary fields, or else the full collaboration like Andy was talking about, where you can actually work with those in those other fields.
Pretty interesting. It's almost in every field we must collaborate with other fields, and it's important to maintain a good connection with others. No? It's interesting to know how it is made in fields that so interesting like those. I have other question, maybe for Dr. Munro, Dr. Gullberg maybe can answer. Considering what you said about Puebla people, could you talk a bit more about how to learn about past astronomical observation and related cultural practice from communities existing today? How do you got to meet that people, the descendant of Puebla people?
So this is a wonderful question, Alberto, and thank you. This is a great example of how developing an understanding of the broader literature was very helpful to me. As it turns out, I have now had the opportunity to meet with members of Pueblo communities and discuss my work. However, I am not an anthropologist, trained in ethnographic survey techniques. There is a fairly well-developed body of literature, starting with, late 19th century reports that perhaps were not created using modern standards, but which nonetheless often have useful data fragments, and culminating in a pretty rich body of material from the mid-20th century onwards. A complicating factor for understanding modern astronomical practices for traditional Pueblo people is that those practices are tightly coupled with religious and ritual practices that in many cases are very deliberately shielded from people who are not members of the culture group. This at first to a Westerner seems somewhat strange. We're also excited about sharing our knowledge, and it's something that we take great pride in, especially those of us trained in science who are pursuing careers in education. But if you imagine for a moment that your traditional cultural information has been driven underground by centuries of suppression, first based on Spanish colonization, later after transfer from the Mexican Republic to the United States of these lands by the Eurocentric members of what was then a US American culture, children being taken away to be stuck in boarding schools so that they're culturally re-educated, traditional religious practices being driven underground because of a dominant church from another place. The example Steve gave of the pillars around Cusco being torn down by Jesuit people, you begin to understand why traditional people in those communities today are not necessarily real excited about discussing their ritual practices. And to them, these practices are inexorably linked to the sky watching. So that's kind of the challenging background. As I mentioned, I have since had the opportunity a couple of years back, based on my results, I actually was invited to meet with a group of people, clan and Pueblo leaders at a place called Hopi, which some of you may have heard of. It's among the most famous Pueblos. And I met the Hopi Sun Chief. But I'm not sure which of the gentlemen in the room he was. They asked me many questions. I asked none, and that's fine.
And you, Dr. Gullberg, you meet some descendant, also native, that helped you in your research?
Could you state that, phrase that again?
Did you meet some descendant, also natives, that helped you in your research?
In my research, like in the Peruvian Andes, the kind of discussions of culture with descendants, no, that didn't so much take place, but everywhere I was meeting people who were descendant of the Incas. The Quechua population in Peru, and a matter of fact, it's been said that there are more people in Peru that Quechua is their first language than there is people in Peru with Spanish as the first language. And you get away from Lima and Cusco, and in all the rural areas, those of Inca descent, the Quechua population, are very, very prominent. And so I spent, certainly much time with people that were descendants of the Incas, but they, even my primary research assistant, Carlos Aranabar, he was just learning about Inca astronomy with me. Although I'm excited now because I've got a friend, a colleague who's a professor at the university in Cusco, who is Quechua. His first language is Quechua. He speaks Spanish, but not as good as he does Quechua. And we are going to write my next book together. We're going to write it together so that I can combine the elements of everything I've learned about Inca astronomy with the oral traditions that has been passed on from generation to generation to generation to him. And then also I've met his teacher, his Amauta. He speaks very highly of him all the time. A very a much older mentor who, again, is even more and has been more engrossed in the oral traditions, the memories, the everything that has survived in the minds of the people since the time of the Inca. So what you're talking about now is something I'm just about to experience in a grand way for the first time, and I'm excited, looking forward to it.
exciting, really exciting. I want you to ask about something peculiar. Do you have a curiosity or something peculiar that happened to you during a research? Dr. Gullberg talked before about a night in Cerro Unoraki, but didn't introduce it. Is that some curiosity or simply a day?
Well, you're looking for an example of what is it, Alberto?
A curiosity or something peculiar.
Just
Something.
just something interesting that happened.
Mhm.
Well, okay, there. You know, in my talk when I was on top of Cerro Unoraki, I mentioned that there was a whole nother story there. I suppose this is a good time for that. When we were down below at Caspihuanca, where that big granite boulder was, looking at the pillars for the June solstice, looking over Cerro Unoraki for the December solstice, I saw something was on top of Cerro Unoraki. And I hadn't anticipated this, and I got my binoculars out and said, yes, there are 3 somethings on top of that. So I started talking to the team and said, you know, we really should check this out. So Carlos, my assistant, we talked to a taxi driver who said, oh yes, I can drive you over there, and we can go up 2/3 of the way up the mountain, and then you just have to finish walking the rest of the way. Well, you know, we went over there, and it turns out we could only drive up about 1/4 of the way up the mountain, and then there was a village there, and we talked. Or I didn't. Carlos was speaking with the villagers in Quechua, and they said oh yeah, it only takes about 2 hours to get up to the top from here. Well, of course, 2 hours, you know, if you live there, if you're acclimated to the mountains, if you're running up and down them all the time, like Carlos, he could run circles around me. We started out, and 10 hours later, I got to the top. And the upper part of the mountain didn't have any trails or anything, just had to, you know, find your way. So we weren't planning on being there as the sun was setting, and the sun was just setting when I finally got to the top. And those pictures were the last vestiges of light that, that we had. And this is now at the time of the June solstice. It's winter in the southern hemisphere. So here we are on top of this, 4377 meter peak. And it's going to be cold. The temperature is supposed to get down to 0 that night. And we weren't dressed for it. We weren't planning on spending the night. We didn't even have flashlights with us. So I'm thinking back to my survival skill days they taught me in the Air Force. Well, we're going to have to try to find a way to just hunker down and spend the night here in the mountain. Carlos says, no, we're not staying up here. We're going down. And remember, there's no trails or anything. So now it's dark. Fortunately, it was a clear night. It was a first quarter moon that gave us a little bit of light. But we're just stumbling through rocks and coming down the mountain in these cucumber-sized things, things that grow with thorns in them that were sticking into our legs and tripping, and I you know, broke my big toenail pretty good even through my hiking boots. But so now we're coming down, and then I'm looking at the village that we left from, trying to find a way to get back to it. And then about 9 o'clock at night, the village disappeared. They just must have had really control over the money they spent on electricity, and somebody throws a switch, and now there's not a single light in town. So now it becomes a struggle trying to find where it was. And plus, not knowing if we're going to have a ride when we get there, I had told the taxi driver I'd give him $50, and he had to wait for us. I hadn't paid him yet, but you know, he expected we were going to be back there hours ago. So I wasn't even sure we were going to have a ride. And But finally, we came out on the road below the village, just below the village, and then hiked up to it. And he was there. He'd gone home and got his wife, and they were there waiting. I guess he wanted his money, but and so he took us out, and all was well that ended well. But it was quite much more of an adventure than I'd ever anticipated. But it got some really interesting research from the situation. It just got a little more adventurous toward the end.
Such an adventure, isn't it? Mm. And you, Dr. Munro, something interesting, something peculiar?
You know, peculiar I will share, and it's not a story I share very often, but I will. You know, we're all empiricists, right? That's what we're either doing or studying to do, or a combination of the two. We are believers in physical cause and effect. We may see serendipity manifested in history, or even find it personally. But from an experiential perspective, all of us as physical scientists like to have a fairly strong bead on what we're doing. One of the first sites where I was able to confirm one of the solstice sunrise events that I was sharing with you is very much off the beaten path. It was about a 6-mile pre-sunrise hike on a June morning to get to this location. I had exactly one person with me, who was my older brother, who had volunteered to come and help carry equipment. And it was the first site where I had actually come up with a prediction based on my own survey data, unassisted by anyone else, the third site I surveyed. And we got to the site and we set up the camera equipment. And it's a very strange place, because this is an outcropping of shale in an otherwise completely flat terrain. So you're 25, 27 meters up above very flat ground, and it's out of the canyon proper on the mesa ridge. So the horizons are almost 100% flat in all directions. 2 small marks on the horizon, one of which I predicted with my survey data in the ephemerides ought to work for June solstice sunrise. And we were happily taking photographs as the sun began to rise, and the horizon marker worked. So it was one of the first indicators that this hypothesis that now has lots of support might have some support. And with the benefit of hindsight, I would have expected, you know, perhaps I would feel a degree of exuberance, right? Oh, my pet theory just got proved. Maybe I'm onto something. Maybe this idea is not crazy. I didn't feel any of those things. What I felt was that I had company. This is an entirely non-empirical, non-analytic statement. It was an emotional response that I felt like I was in the presence of other people experiencing something with them. And I can't explain it any further, but it was a very memorable and fascinating moment.
It's beautiful. Feels something like that.
Yes.
The last question before going to the public questions. How do you think physics students can be motivated to learn about history and cultural aspects for physics and astronomy?
That's a good topic to bring up too, because for so many of our colleagues, their first field is not archaeoastronomy or cultural astronomy. Their first field is another science or another field of some sort. But this is such a fascinating area of study that it captivates you, and it's something that even if you're doing something else for your primary vocation at a university or other research, many do research of astronomy and culture in addition to that, just because it's a passion, and they take the skills that they bring forward from their other sciences, so they are doing some very credible work. It's not really amateur work, but you know, like you have astrophysicists who also work with archaeoastronomy. You have anthropologists who also work with archaeoastronomy, archaeologists who also work with archaeoastronomy, astronomers who archaeoastronomy, physicists who work with archaeoastronomy just because they are fascinated by it. And it is, like you've just gotten a taste of in the last hour and a half, it's a very fascinating area to study.
And I would share some additional thoughts. I agree entirely with Steve's point. To your question, Alberto, I would also share that much of my career has been outside of academia. And I've spent many years working in environments with commercial intent, right? Corporations, but with many people trained in physical science and engineering. A lot of that work, it's focused on very pragmatic things like building telecommunications networks or, improving the safety of transportation systems or what have you. And I think many of the folks who are with us in this meeting today may find that their studies in physics lead them in that kind of direction more than to the academy. I'm convinced that to the extent we're able to get broader education in the history of our discipline, the history of disciplines that we work with, and how those disciplines work within a culture, within our culture, the more we learn of that, the more effective we can be as human beings doing the work we choose to do. We talked a little bit about this before the general session. The best example I can think of is if you just imagine, well, we'll think about a fairly, and this is random, frankly, but a fairly hideous example from human history. Many of us are at least dimly aware, if not fairly aware, of the events of the Second World War, a global conflagration with many horrible things happening. There were fairly large numbers of people trained in physical sciences who, for reasons of serendipity, good luck, bad luck, the nation they happen to be born in, simply end up working on a team for a problem that is being focused on a military objective in the midst of a terrible war. Unpacking how you behave in that kind of extreme circumstance probably sounds like an alien thing for most of us. But even on a day-to-day basis, if you're working in a commercial environment, working on some project for a corporation, and it's helping to pay your living, and your skills in physics are the skills that you're bringing to the table, there will be times when decisions need to be made that are not physics-based decisions. They're ethical decisions. They're decisions that need to be informed by history, by cultural considerations. And I think even in that way, it's something of value for all of us. That probably sounds pretty theoretical, but in my own life experience, it has turned out to be true. So I would share that thought, that's sort of from the inside looking out as someone with a science background doing a job, having that kind of broader exposure can sometimes be very helpful and certainly enriching.
Okay, thanks. Now we have questions for the audience. The first of all, someone asks, what advice would you give to physics students considering this field in terms of studying or exporting material or documentation?
Steve, would you like to start or would you like me to?
Go ahead.
So I think if you find you already have a nascent interest, in the short term, probably the best thing you can do is just think about the design of your own course of study. Wherever you are in your educational progression, there are probably options available to you. Certainly, if you're studying at an undergraduate level, your choice of electives, may well be influenced by this interest. So that's something I would suggest you think about. And to think broadly about which fields make sense, right? We've talked about anthropology and archaeology heavily. History of religion and history of science, I think, also are both of great importance in understanding this work. One of the unique perspectives I've come to, having done this work for over a decade now, is not something I was taught as a graduate student in astronomy way back when I was working on my master's degree. I was taught that astronomy was the first science, and it arose through this sort of linear progression from the Babylonians through to the Greeks. And right, this is the way it is, and we're the first physical science. Fine. I never really learned the degree to which cultures around the world used observation and prediction in myriad important ways. And that while it may not be an empirical physical cause and effect truth for us, even if we think about the people at Chaco Canyon over 1,000 years ago, they built a thriving civilization in a really harsh place. Their cultural practices created a form of truth that enabled them to achieve more. So too, at an individual level, learning more about history, just in your own general reading, if you're interested in archaeoastronomy, beginning to perhaps pursue a personal reading list, and also thinking about your own educational plan, are all ways that you can kind of broaden the base of your experience in education.
Dr. Gullberg, something to add?
No, what Andy was saying is exactly right, and we started out earlier talking about the interdisciplinary nature of archaeoastronomy, astronomy, and culture, and the kind of I don't know, skill or insight or whatever that brings to those in their own specific fields by getting them to broaden their thought and to think in other terms besides just, like for me, besides thinking just astronomy. I think with anthropology, with archaeology, same thing with Andy, with you, instead of just physics, you could be thinking of in terms of other areas, other fields, looking at things from different angles as well. And at our university now, not just in our archaeoastronomy program, but the entire university and all its programs, there's a big push on right now for cross multidisciplinary research, getting researchers together on projects that are not all from one department anymore. They want to get people from multiple departments together so they can look and solve these problems with thought processes that aren't just focused in the area that they were trained in. They can look at a much bigger picture and come up with hopefully better solutions.
Thanks. The next question is very related to the last one, and we talked briefly before going to live at 7. Do you think there should be a common basis on historical, cultural, and anthropological aspects learning in physics and astronomy courses?
There should be a what about physics?
A common basis on historical, cultural, and anthropological aspects on physics and astronomy courses.
That'd be very valuable. And we haven't really talked as much about establishing that with physics as we have like with anthropology, with archaeology, but I've got colleagues right now that are in the United Kingdom working very hard at trying to put cultural astronomy education into actual archaeology degree programs, and that same sort of thought it would be valuable in physics education to at least have a course, if not more than that, that would try to educate the student in the cultural aspects of physics, of the study of the different areas, not just history, but why and how has this been used to help cultures, in a much more historical sense than just what we currently do with physics in our cultures.
I would also agree. And one of the things that I reflect on that's so interesting is that a society like yours, I think, is particularly well placed to think about these kinds of issues. When you go from institution to institution, place to place, nation to nation, our standards are actually quite variable. I know that when I did my undergraduate degree, studying physics, we still had fairly high expectations at my particular university for a pretty broad liberal arts and sciences distribution requirements as undergraduates. You know, you had to take some humanities classes, you had to learn a foreign language, things of this nature. Increasingly in the US, I see less of that, while at the same time I'm familiar with other countries where it seems to be more prevalent. All of my life experience, my professional experience, and the research we're discussing today has convinced me that that is more important than I ever realized when I was younger. So even to the point of, as I was mentioning earlier, selecting courses of study or selecting institutions, the conversations you may have with leadership at the institution where you're studying, having the ability to broaden the base of your education, whether it's in cultural astronomy or history of religion or art, any number of fields, if you really get beyond a just cursory exposure and begin to understand the degree to which people's ways of thinking, their ways of behaving, their ways of operating in the world are colored by all these different domains, I think it just makes you much more effective. We have a cultural tendency to over-specialize because it works very well. You get better physics answers from trained physicists than you do from generalists, unquestionably. But I also know from all of my career experience that every time I go into a room to work on a particular problem with a team of people, the first thing we need to do is collect people with lots of disciplinary backgrounds to frame the problem. So there's a yin and a yang to it, yes?
Thanks. I think there is no more questions. I can see anyone. Okay. So that was the last one. So the speech is finished. Thanks to both of us. This has been beautiful, a wonderful experience, very interesting, and I'm sure that the public has enjoyed as much as I did. Thanks for coming. Thanks for staying with us and explaining the beautiful and interesting theme that you study. And something, do you want to say something to the public?
Well, thank you for inviting us. We both, as you can tell, enjoy talking about this very much. And it was a pleasure to be able to do so with you all this evening. It's always nice to be able to talk to people who don't know necessarily a whole lot about cultural astronomy, because it is fascinating and just gets, opens the door for thought in a different direction than you've considered before. And now, even with what you've seen that I showed you and what Andy showed you tonight, you might, when you're outside, think about the sun and the environment and what's going on just a little bit differently. We don't, in our 21st century culture, we don't often take the time to stop and really think about what's going on in the sky, like the ancient cultures paid very close attention to. So now that you've all been exposed to that, maybe you'll take and pause and think a little bit more about what you're seeing, relating to what we showed you just in the last couple of hours.
And I would also like to thank both of you, and for everyone who's joined us for the meeting today. I really appreciate the opportunity to share the work, appreciate the wonderful questions, and it's quite nice to be able to speak to a group of non-specialists who have interest, and frankly, to speak to a group of people who are embarking on your studies in a field that's directly connected with pretty much my entire career. And so that's also very enriching for me. And I hope that the talk that Steve and I have shared with you today is of value to you, and appreciate your time.
Thank you. So maybe our technical Duarte, this is finished.
I would just ask everyone that's watching to continue following the IAPS at a distance calendar of online sessions. And I also would like to thank Dr. Gullberg and Dr. Munro for being present in this wonderful session and for showing us the many wonders of this field. And I definitely think this was very memorable also to me, as I had mentioned to you before. And hopefully it was too for the people watching us live, and for everyone that might watch us later. So thank you very much, and have a nice day and continued work.
Thank you very much.
Thank you very much.